A short circuit occurs when a current flows through an unintentional path with little to no resistance, causing a large amount of current to flow through the circuit. It can cause explosion and fires due to overheating. The total current in the circuit drastically increases from the nominal current, and can damage other circuit components or devices. The figure shows circuit 1 where a battery of V volts is connected to 3 resistors, R1, R2 and R3 in series between points P and Q. Each resistor is shorted, so the equivalent circuit is a battery which is shorted. Circuit 2 where a battery of V volts is connected to 2 resistors, R2 and R3 in parallel between points R and S. There is a short circuit between points R and S in parallel to R2 and R3, so the equivalent circuit is a battery which is shorted, as the current always takes the least resistance path. Faulty insulation or loose connections can allow the live and neutral wires to touch, causing a short circuit. An overloaded circuit can overheat and cause a short circuit. Water in contact with the circuit wires can cause a short circuit. The figure shows a short circuit when live and neutral wires touch, and a short circuit when a circuit is overloaded and causes a fire. Since the current path has little to no resistance, a large amount of current flows through the circuit. The current through a short circuit is infinite. In a series connection, if a short circuit occurs, infinite current flows in the circuit. In a parallel connection, if a short circuit occurs, the whole infinite current flows through the short circuit, not through the other parallel branches. The figure shows circuit 1, where a battery of V volts is connected between points P and Q. 3 resistors, R1, R2, and R3 are connected in series and each of the 3 resistors is shorted. The current between point P and Q is infinite. Circuit 2 has a battery of V volts connected between points R and S. 2 resistors, R2 and R3 are connected in parallel and a short circuit is in parallel to these 2 resistors. The current I2 through R2 and I3 through R3 is 0, and that through the short circuit, I1 is infinite. As the current always flows through the least resistance path, the total current I is infinite. The resistance of a short circuit is 0, since R equal to V by I, and I equal to infinity, R equal to V by infinity, equal to 0, the figure shows that as each of the 3 resistors R1, R2 and R3 is shorted, the current I from point P to Q is infinite. The equivalent circuit is the battery whose terminals are shorted. The resistance R, A, B is 0. The voltage across the short circuit is 0, since V equal to I into R equal to 0, and I equal to infinite, V equal to 0. The figure shows that as each of the 3 resistors R1, R2 and R3 is shorted, the current I from point P to Q is infinite. The equivalent circuit is the battery whose terminals are shorted. The resistance R, A, B is 0, so the voltage V, A, B is 0.